Live. I think it's live now. No, and now it's live. Now it's live.
Hi guys.
Hi guys. Hey everybody. How are you doing?
We're missing a member. He's in makeup still.
Yeah, still in makeup. Yeah, you know this takes its time. Yeah, so bear with him. So how is everybody doing tonight? And no, we're not 1 hour late. I think everybody's 1 hour early or something. Yeah.
1 hour late. They haven't changed the time yet. What I know.
Yeah, this must be something real time zones. Don't get me there.
Time zones are horrible.
Hey Chris, hi Long, hi Gordon, hi Paul, Duchess here of course, Erie 1988, and Gordon of course. Good evening everybody. Oh, there comes the man.
Yeah, hello. He's done.
Yeah, you're looking better, yeah.
Just a quick pee. We're on.
Mm-hmm. Yes, of course we are.
Nice one.
Get around.
Hey guys, sorry about that. That's a paying visit to the little boy's room.
No, they weren't going to believe you.
No. And when I got there was no little boys there. Get myself my coat.
Yeah.
Okay. Cheers, guys.
Cheers.
Only Co's here at the moment. Be you later.
Energy drink.
Okay. So, how are you all doing? Yeah. How is everybody?
They're coming in. They're coming in.
Yeah.
Oh, good. Hi SX64 man. Yeah. Hi One Dog.
Hi mate.
Chris Hartley.
The parade is late as usual. Yeah. Nice one, Chris.
So we have. What do we have today?
Well, you showed me something off
This
camera.
is going to be a chaotic episode.
Yeah.
Yeah.
We have something to try to not destroy today.
I have to move some stuff out of my way.
Yeah, and move your cola so it doesn't fall.
I know all this stuff is still on here since last
Yeah, it's a little Casio thing from last from a fortnight, still laying.
And
the mini Sims thingy.
Yeah.
Yeah. It's missing the middle finger.
It is.
16 degrees in the centigrade in the UK. Wow.
That's actually quite hot.
Do you guys already call it summer or what's going on?
No,
16 degrees.
They're declaring a heat wave again.
Yeah, I think so. Yeah,
That's as warm as it gets here at the coldest minimum at night. 16.
Yeah.
Well, come on, we had 14.
Yeah, we had 14.
We had 14 last night. So at night, not in the day. That was the minimum.
No.
Yeah, I agree there. It was nice and toasty during the day.
Yeah, exactly.
Lon says great lessons this week on the channel, Richard. There you go, my friend. Yeah.
Thank you.
You're doing something right there.
Yeah.
I actually learned something this week. I was looking into database. So you guys probably saw the video with the this thing with the toroidals. So it seems to me that I always thought that on a Class D amplifier, these coils,
Inductors,
toroidals, these things that you find on the output of Class D amplifiers, I thought these were just there to filter out all the high frequency switching noise to stop it getting to the speakers. This and some capacitors. And it turns out from what we discovered on this, that is not the case. If this has shorted turns in or the impedance is too low, the MOSFETs, which are switching this high frequency, pass too much current.
Yeah.
Because when it switches the MOSFETs on, instantaneous change of
it's
voltage.
Like a choke.
Yeah, it's like a choke. So and hopefully some of you guys also discovered that this is more critical than you might think. Because when the MOSFET driver switches the first MOSFET on high side or low side, the center point, the speaker output, instantaneously goes to 42 or minus 42 or whatever the HT is, and that causes a surge of current.
Yeah, pretty large.
So this choke there stops that surge of current.
Yeah, because the magnetic field
opposes. Exactly. So and the capacitors obviously they bypass, so they take any remaining spike AC to ground, but they are passing the current, the AC. Yeah. This is blocking it.
It's
so
3 minutes in and this man is already talking right along the way, all technical.
Sorry guys. So what I would say to any of you guys, if you haven't realised this by now, if you're working on things like Class D amplifiers, whether they're car amplifiers or whether they're big ones off active speakers, if you've got blown MOSFETs on the output, then check the choke, which is in series, so it goes from the junction of the two MOSFETs to the speaker. Check the choke. The only reason the MOSFETs didn't blow up on this one is because the driver chips, when we found the data sheets, have protection, so they monitor the current going through there.
Okay, so they turn off. before they
They switch off before they blow. Yeah, they measure the voltage across the MOSFET when it's switched on. And obviously ODS on is a certain amount and they know what it should be within spec. And if there's too much voltage, switch off. So guys, I would have never thought it.
Good evening, Roy. Good evening, Tim. Good evening, PM Chris. Be back. I think we hadn't had the pleasure. Good evening, my friend. Yeah.
So while we're on that topic, we know Carlos is very good at breaking things.
Yep.
But today we don't want to break something. I can't find these things to buy. I mean, you guys had a quick look. I know some of you guys.
Not in that package.
Not in this package. And the way this is designed, so you have like this housing it fits into, and the inductors go under here, which then goes inside this. So this goes together like so.
So you have a little bit of space.
So you have a little bit of space. That's where the inductors sit, in there, in front of those capacitors. And when this is assembled,
there's not much space. No.
There's not much space. So this is why we need to have.
So you could have a toroid, but it will be double the size of this.
Yeah.
Pretty much.
So anyway, anybody any ideas before we?
Wait, Lon, I can answer this. I can answer something.
Okay. Okay.
0 ohm resistors are normally there to do bridges on a single-sided PCB.
It's like a wire.
Yeah. If you have a manufactured PCB, it's easier to have a form factor like a resistor that simply has 0 ohms and to a little wire.
Yeah. It's so the pick and place machine.
The machines can handle this.
Yeah, because the pick and place machines are designed to place resistors.
Yeah.
So 0805, you know, 0805 resistors are standard form factor, or 1206.
Yeah.
So if you make a 0 ohm resistor, it's the same as a piece of wire electrically. But the pick and place machine can just pop them on the board.
Yeah, and they're replaceable, like fuses. There are people that use them.
No way. Rory is in the hospital. Rory, my friend, what's going on, mate? You fine? Don't do that. Hospital is not good.
Yeah. Depends on if he's getting better from the hospital.
I hope he is.
Not like me. I go to the hospital all the time and no improvement whatsoever.
Okay, can we get a picture on here?
Yes, if you do the thing here when you...
Oh yeah, we have a new setup now.
Yeah.
Press F11 for full screen.
I was wondering what you were doing. Why is it the image squished?
It's crap.
Yeah, we noticed that the aspect
again.
ratio is slightly out.
Deactivate, activate.
Okay.
Oh, no, there we go.
Yes, sorry guys, we'll figure out how to get the aspect ratio.
Jonathan already has a thing for you, yeah. Mauser, there's a Mauser number.
Oh, right. Okay.
Jonathan, is that 6.2 amp?
Click on the link.
Fainting. I can't click on the link on here.
Oh, fainting.
This is no link.
That's not good. Yeah.
I don't know if you can send it to somewhere we can see it.
Talk amongst yourself, I have to
Just be careful so you don't faint in the wrong place.
Okay.
I've done that and I almost cracked my head open. So.
Okay, so this is the thing. We're just seeing if we can buy these from Mauser.
If you found it already.
But the question is, if you look at this top edge, to me, this is just molded. This is
it looked like it was a canister, but
this is molded. So I think we have like a canister thing, and then this is glued into the bottom. If you look at the other one, the good one,
so we have the good one.
8.9 amps. Yeah, this is fine. Yeah, 22 mic.
Perfect. What's the dimensions?
That's the thing.
12 millimeters.
Can we measure this?
Yep. If you have a
we do
ruler.
have.
Oh yeah.
The battery is gone. Won't work.
It doesn't matter. We can use the ruler.
You don't need batteries to measure these. About 8. So that's fine.
It's 15, isn't it?
Is it? Oh yeah.
No.
Yes. No. You're right. It's 15. Exactly.
About 15 millimeter wide. How big's that other one?
That one's 12. So
that's fine.
You have to open the legs a bit.
Oh, okay. Are we reducing the level of the broadcast already? Okay, excellent.
It's already in your WhatsApp.
Thank you. So I'll show those guys off my phone the picture.
But
while we're here,
open it.
While we're here, shall we see? Not this. This is the good one. Shall we see if we can get the low part?
Yeah. So there is a small difference between these.
Why is this crashing all the time?
I don't know.
crap, sorry.
So one is indented and one is not, as you
The
can see.
indented is the good one.
Yeah, the indented one is the correct one. Richard, this popped out when Richard heated it up to get it off the board.
The leg, yeah.
Yeah.
Sorry, Gordon, I didn't see the screen while I was looking at the
So
mouse thing.
my guess is the epoxy got soft and then it slid out. So we're going to try to take off the lid here and try to rewind this thing, because this should be very thick wire. Actually, the magnet wire is showing there. So this is actually part of the wire. So.
Paul says the extra holes up when unscrewing. That could be. You see the holes in
Yeah.
there were no wires in there.
Okay.
You could poke some really fine pieces in there.
So is Paul saying that this is threaded, so it won't pull out?
Could be.
Is that what you're saying, Paul? It's threaded.
No, but I would. Considering this actually came out by itself when he heated it up from that, and
so,
he didn't spin it.
Okay, no, I think that might have already been like that.
You know, simply try this. Try if it moves when you try to turn.
Give me a sec. I see something inside. There are no threads.
Oh, you can see on the one that's already part way in. There's no
When you go a bit
threads.
more down, people can see.
Oh, sorry. So there are channels for sliding up.
There are channels of sliding up, but there's no thread. Okay.
Yeah, so that's good. Sorry for the blurry picture. Let me fix that. There we go.
Right. Okay.
So yeah, that's
So they won't unscrew then?
no. But I see epoxy on the corners.
On the good one?
Yeah.
Yeah?
So you can see some leaking out on the side.
Is that epoxy or is that the enamel on the wire?
I think that's the epoxy. There you can see some epoxy. So they dripped epoxy in. That's why this got loose when you heated it up, pretty much.
Okay.
So it's just heated up a bit more and grab it with some tweezers or something, and they just
So
pull it
you
up.
think maybe you can hold the thing in some mole grips or something?
Yeah, pretty much.
Okay, let me find some tools.
Yeah, a couple of tweezers
And we need hot air.
and hot air. Yeah.
Yeah, heat gun indeed, Rory. Yeah.
Or heat gun. Yeah.
Good evening, Patrick. Welcome to the show.
This should be
Orion. I see so
fixable.
many new
What will these
names
different
here.
tweezers?
Yep, those will work perfectly.
Great to have you with us, guys.
Needle nose, perfect.
Oh, wrong camera. Sorry.
Yeah, needle nose. Okay, this fit. So this will let me work it out.
Paul says use your holes to turn it back and forth 10 degrees. So to just wiggle.
Yeah,
wiggle it a
Well,
bit.
can we turn it 10 degrees?
We can't.
Look at this again.
It has small grooves it sits in.
It has, there. Look, it has like small grooves. They almost like there's glue behind them themselves.
Yeah, there are glue behind them as well. So those could.
How did it get in there? I would heat it up and
Yeah,
simply
I
try
agree
to,
with heat.
Okay.
Yeah.
So the El Crapo.
The El Crapo tipo thing.
Yeah,
Yeah.
and
I assume if we get this out, we just need to count the turns and measure the wire gauge.
Or simply buy a new one from Mauser.
Well, yeah.
yeah. In this case, yeah.
In this case, yeah.
But there is a point to doing this
Because
if
it's
you-
educational.
Yeah, and if you can't find the parts, you need a way to fix them.
Like we get the metal tray, you can put it on while you're heating it up.
Yeah.
Sorry.
There we go. The El Crapo station. That's better than mine.
Really?
No, it's the same brand. So I'm guessing it's the same.
We should form a brand call it a Crapo.
A crapper.
Yeah. I would buy that.
I'd definitely buy that. I mean, before you do this, do you
Who's in, guys?
Do you want to warm the whole thing up on the preheater?
Nah, doesn't need to.
Okay, we need to get a camera where we can see it.
Okay, so max temperature, good. So this will take a while because this is a ferrite casing with a ferrite core. So this is all metal, pretty much.
This is why I want to put it onto the preheater.
Tremble the drum. I think, Paul, this would be counterproductive because we want to try to keep this somewhat.
So the impedance will probably be incorrect if you put in the same turns. Then you have to faff around with the turns because you will lose.
Maybe give it a bit more time because the heat wouldn't spread very well there. May take it a bit further off. So
I was going to put it onto the preheater as well as the hot air.
Yeah, no, it's fine. I want to
Patrick,
concentrate.
El Crapo, please.
El Crapo, yeah.
So viel Zeit muss sein.
Oh, move.
Didn't move.
Yes, it did.
Oh, it did
It
move.
moves.
Can't you grab it by the wire and pull it out?
Yeah, I could probably do that actually.
Guys, slowly.
And then the other side.
Slowly.
Yeah, slowly.
Yeah, well, that's exactly.
Oh!
It is,
Oh, Luke!
It is coming.
Slowly, slowly, slowly.
Yeah, slowly so we don't break it. Oh! Oh, Luke! Keep going.
Yeah, I'm going to grab the other side.
And hit it from inside.
Yeah.
Oh, there are not many turns.
No.
Oh, probably epoxy. Do this
No,
very slowly.
the turns are still inside there.
Well, the turns won't matter because we can measure the lengths.
The length of the wire is.
Yeah.
And the diameter.
Yeah. The diameter is around the core anyway.
We can, so we can wrap it back around and see how many turns. Or we can, if you keep it like a string, we can count the turns.
Indeed.
Well, keep going.
Yeah.
Bit lower.
We don't need to count the turns if we have the length.
Yeah.
And that'd be still easier, isn't it, if we keep it back?
Yeah,
So it's
you're
like
probably
a string.
right. You're probably right.
Yeah. No, you're right. That it's easier, but if we uncoil it, it's fine.
Keep going.
Yeah, I'm going slowly.
Wow, this is.
So this is a lot of epoxy.
So at least one of the subscribers said he's never managed to do this. He's always ends up breaking. So yeah,
Heat.
heat.
Heat is the trick.
And this is only a cheapo hot air station.
And it's running at 500 and we got everything out and
Hot.
Okay.
it's hot.
Yeah, it was. I touched my finger.
Okay, guys, that was a
Interesting.
success.
Yeah.
So we'll let it cool down. Then we should be able to count the turns.
Yeah. So if you coil it around the core, you should get the exact turns because
Yes.
it was coiled around this core.
Yeah.
The hot air gun of knowledge.
Yeah.
The Slinky is free. Yes, we'll remember
Yeah.
Slinkies.
So it has a ferrite casing with a ferrite core.
And gluey goo.
Yeah.
And we have epoxy. Last time we glued something together, remember?
We can put some epoxy in it.
Yeah. This is epoxy. It smells like epoxy, so.
Yeah,
It is.
yeah, of course, Paul.
Yeah. Paul, yes, we can count the turns because it's still like a spring shape.
But how is this shorted then?
Well,
This was what I was thinking.
okay, so it was reading about 1 microhenry in circuit, and the good one was reading about 20.
Yeah. But,
Okay, when I took it out, and obviously it pulled the leg somewhat.
Yeah.
The good one was reading about 20, and this one was reading about 10. So it was still reading half of what it should have done.
Yeah, but still, I would want to know how it fails because it doesn't move inside. It has epoxy.
No, but okay, I think it fails because if somebody's overdriving the speaker.
Oh, it arcs in between.
Well, not
Yeah.
so if the speaker's clipping, you get to points where it's just passing DC.
Yeah.
And it's
heats up.
switching between like something like plus and minus 70 volts or something. So 140 volts is high frequency, and just abuse. I think that's the only reason I can think. Why would it
Anthony
get
asked,
shorty turns?
could you re-enamel the wires?
You can.
Can't, I don't know. They
You
clear
can.
it up.
You can use PCB solder mask, and it's the same thing.
That's the same stuff indeed. Yeah.
Yeah.
You're right.
So-
Whether it would withstand the usage.
It should.
Okay,
I wasn't it.
can I ask?
Did do.
Can I ask you guys, how many of you thought that this wasn't going to work? Because I thought there was no way.
Here's one.
I'm one. I thought there was no way Carlos was going to get that out of them in one piece.
This is still hot.
So, out of interest, guys,
Yeah, do not squeeze that, please.
who thought it would work or wouldn't work?
Okay, that one's hot.
Yeah, leave it to 5. I mean, these are hot. Everything's hot.
Yeah.
We put this
The
on
wire is actually not hot because it's copper.
Yeah.
We put it under the microscope in a second. So.
Yeah.
It's still very hot, guys.
Yeah. So I don't want to burn my fingers more than I have already have. So.
SX-Man has an interesting thing there. If this is just a filter, couldn't you bypass it to test the clicking?
No, this is the point I was making. It's not just a filter. A Class D amplifier, the output stage, has a high side and low side MOSFET, which is switching at high frequency, hundreds of kilohertz. And it's driving a coil. It's driving a coil, so
it's really hot.
the output of the Class D amplifier is like buck converter, a DC to DC converter, similar to a switch mode power supply, and you just pulse width modulating. So normally, you know, if you want more voltage, you increase the pulse width modulation or decrease. This is just modulating the pulse width modulation at audio frequencies. So it's changing very rapidly, and that's what gives you the varying voltage output. So it's like a power supply, really. So it's like saying, well, can you take the coil out of a buck converter to see if it solves the problem? You can't. It's an integral part of the circuit, and this is why, although yes, it filters noise out of the speaker, the circuit can't work without it.
It doesn't vibrate, so let's say.
Yeah. Without the inductor, the right sort of inductance, then as soon as you switch the MOSFET on, it's just got a short to ground.
Yep, pretty much.
And that's why.
Okay, give me a sec.
Okay.
I'll rewind this.
They're just doing the magician. They're just pushing it back on now.
Yeah, pretty much.
Okay.
Yeah, don't worry. I know what I'm doing.
So
he says this all the time.
And it works most of the time.
I have to say, to me, this was like another moment of epiphany. I suddenly realised that these inductors on the output are an integral part of the circuit. They're not just a filter.
Yeah.
It can't work without it.
Because it chokes the current.
Well, it's like the inductor in a DC to DC converter. That's what it's doing. It's just modulating the pulse width modulation at high frequencies. Well, audio frequencies.
Okay, so this was...
So no, it's not just a filter, guys.
So it's...
And that's why I say, if you're repairing these type of amplifiers and you ever find you've got shorted output devices, check the inductor.
There we go.
I mean, hopefully it'll be a stereo amplifier, so you'll have two of them.
Yep.
And I showed in the video how to check them with a ESR meter and work out the inductance.
That's good.
So Carlos is just roughly putting it back to the air there.
Yeah, it's not working as well as I hope because it has epoxy in between.
Okay, well don't worry too much, as long as we know how many turns there are. Yeah.
Yeah, they are. Okay, so let's fix this so there are somewhat the same size.
Okay.
Okay, how many turns are at the bottom? There are 2.
Oh, almost lost the butt plug.
Ooh.
Okay, let's look under the microscope. So this is the little housing it came out of.
Yeah, very squished because the aspect ratio is wrong. And
we must sort the aspect ratio thing out.
You maybe want to pull the focus there. Oh, no, you got it.
oh,
So that's the actual thing. So I need to find some solvent to clean all the rest of that crap out of there.
yeah, acetone.
Acetone, okay. And then this is like the little butt plug, sorry for me, that goes inside it. So this is what the wire was wrapped around.
Quite frankly, we would need to order the wire anyways.
Yes.
I don't have this wire in this.
No,
No, but we should be able to measure the wire.
But
I
you know
do
what?
believe we have to.
If they go new for 40 pence, I would buy simply a new one.
Yeah,
It isn't worth the hassle.
What for Mouser?
Yeah.
Yeah, it'll be 40 pence for the thing and 20 euros for the postage.
But we need to order the enameled wire.
Enameled
wire.
Enameled.
Anyway, so
Well, we can if I replace it with a new one, I can still rewind this. I can use a little clip from this video, so I'll make a video of it. We can measure the gauge, and then I can measure the inductors when they're finished and see whether it's correct.
Okay, let's check the gauge first.
We've got something better than that for checking the gauge with.
You have a real one that works?
We have those PCB rulers.
oh, you got a new member here.
Hey!
JSP.
Hi mate, hi!
I'm guessing,
Welcome.
Guessing from India, from the name. Correct me if I'm wrong, please.
We appreciate it. Thanks.
Let me just try.
Yeah. How many turns is this? 1, 2, 3, 4, 5, 6.
Robert, I'm always saying this.
9.
For my taste, this is way too much work. And if you mess up with a thing,
So-
now you have to clean up the inside of the inductor thing, which is going to be a pain in the butt. And
A Dremel and a brush tool we do quick work of this.
I don't know that.
But I agree with you, except for all the electronics that don't have a replacement. Then this is actually useful. In this case, there is a working one.
2 of them.
None of them work. No batteries. I'm pretty sure.
I can't remember for the life of me. I think it was a battery problem, yeah. And the battery was in the just fapping around in the breeze.
Do we have the PCB way ruler there that has all the little holes drilled?
Yes, of course we are.
Okay, excellent.
Do you want to have a green one or a white one?
One with holes in.
One with holes on.
So these are PCBWay rulers, and you can probably see at the end opposite my hand like a graduated set of holes.
You don't need to be a YouTuber, you can actually buy them.
Can we see this?
Yeah.
I think we can.
Yeah, we can probably.
Yeah, you can buy these from PCBWay.
You maybe want to zoom out because nobody can see what you're doing.
Look.
Let's zoom out a bit.
Zoom out a bit, yeah.
Oh, I can't reach.
Not easily. So
No, they can see what it has.
this is showing you in millimeters, and I think it's AWG. I'll probably say at the end of it. Yeah, AWG. So you poke the wire through the hole. Once we know how many turns we have, so this is the wire.
Now, don't forget you have some solder on.
And I will zoom out a little bit. So
Oh, this is an idea. Use an HSS drill bit to clean out the casing. This is an idea, Joe.
Yeah, that works as well. As long as you have the correct fit, that should be fine. Or
put it on a hot plate for an hour too. Yeah.
yeah, that will burn out everything as well.
Okay, so we can
Because
see
it's a
it.
ferrite casing, it will handle the heat.
Yeah.
So how many turns?
Luckily
do we
for
have?
us, it has metric on the side there too.
Yeah, we don't use AWG.
Yeah.
4, 5, 6, 7, 8,
13 torque.
9, 10, 11, 12 or 13. 13 turns.
Yeah.
Okay, so 13 turns of this stuff. And then we just poke it through a hole. Just find a hole it fits in nicely.
Pop the thing.
And don't forget there is solder on the tip, so it's probably the hole it doesn't fit in.
It
Exactly.
just fits in that one.
Yeah, so it's probably a 1 mil.
So that one it goes in.
It's probably a 1 mil wire then.
Yeah. So it's 18 AWG.
Yeah.
Or 1 mil. So if I get some 18 AWG or 1 mil enameled wire,
Yeah.
which I can order
From AliExpress.
from AliExpress, then we'll rewind it.
Yeah, and that should work. Just keep these safe because these break really easily.
I'll put them in a nice bag, and then I'll update all this on the on my channel. So I'll order the stuff and I'll show. Right? I have a Dremel. A real one.
Use yeah, I don't have a real one.
I don't have a Dremel-ish. I have a Dremel.
Use a brush tool to clean off, and you should be fine, Richard.
Yeah. Okay, guys, success.
Want to write down the amount of turns?
13. Unlucky for some.
Yeah, no, I mean on the bag, so you don't forget.
Yeah, the other way would be to stretch it straight like you say, and then just
yeah, measure
the length, cut the same length, and wind it off.
Yeah, and epoxy. I think we have some liquid clean epoxy.
We do have some clean epoxy
lying around because we used it last time.
13 turns. Okay. Excellent.
I know I forget what I'm doing a week or so after when I'm doing projects, so I think.
I'll just show you guys these, by the way. So you get from PCBWay. Not trying to sell them anything, but
No, we don't get any money for these.
you know, PCBWay, and then you have on here all the different footprints, the different sizes, so you can put your chip against this, whichever space it fits, and it tells you.
I like the sizes for the components on the bottom.
Yeah, crystal oscillator. Let's keep going. Look, deep arc. So you just hold it against this, and whichever one it fits against, that's the footprint. If you want to know, look at for diodes, SMA, SMP, or whatever.
Yeah, and all
mini
the
MALF, all these MILFs. Look, 0201, yeah. So this you guys might find interesting, by the way. So where you see like 021 and then brackets 0603, 0402, 1005. One of them is metric and one of them is in hundredths of an inch or imperial. So you'll see there's an actual fact. There's two different, and you have to be very careful when you order, for example, like 0603 resistors.
Yeah,
Or you're getting metric. In fact, it says above it metric or imperial, yeah, and they're different.
Yeah.
And I've done that. I've ordered like 0603 and got these tiny things, which are actually 0201.
Mm. In the 0201s are pretty much impossible to solder on.
They're like dust.
Yeah, they are grains of sand, pretty much.
Anyway, you guys might find one of these useful PCBWay rulers.
Yeah, they're quite cheap. You should get 5 for less than $5.
Yeah, it's like ordering a PCB. It's like a shared project.
Yeah,
PCBWay
it's
ruler.
a shared project, exactly.
Yeah, look.
Thanks a lot, C voltage for the silver supporter.
Oh, thank you very much. Thank you very much. It's all much appreciated.
Much appreciated. Yeah, we do this for fun.
Dutch asks, next question, what makes the inductor fail?
Yeah, we can measure it. Measure the wire.
You can't measure it now.
Yeah, but if you measure the wire now, it should have this.
Dutch, I would guess heat.
Oh yeah.
Because it's enameled wire, so if you put immense heat in there, this is probably why the thing just simply melted.
Well, it's out of a speaker. Let me show you the speakers this comes out of. I'll just show you guys.
So there are two failure modes there. Heat is one of them, and you're right. But vibration from the actual coil line could also rub in between if you haven't enough epoxy inside.
So this is what they come out of.
Oh.
They're fairly big, yeah, but you can see me back. They're quite big speakers. So right behind this is the bass speaker in the bottom.
Mm.
So you've got a mix of heat,
Yeah.
vibration.
Yeah.
These things being thrown in.
Yeah, it rubs off the coating. If there's not enough epoxy inside, it will move. And,
Yeah.
Right.
These belong to some girl who's like a bar restaurant singer. So they're getting thrown in and out of the car. All the usual things. I think it's just a very bad environment for a coil.
Yeah, true.
And you can see where this fits right into the guts of it, so there's not much ventilation around it.
Yeah, but if you fill that up completely with epoxy, that should hold better.
Yeah.
Yeah. Of course, ordering a new one would be preferred. I agree with that there. But in the case of retro and stuff that's rare, you need to rewind coil sometimes. Yeah, well, you don't have a choice.
Yeah, I hope this is. I'm going to put this on one side.
That's the first time. He's almost dropped it like 3 times in 1 minute.
Right, I've put that away safe. Yeah.
Let's put this.
That would be hilarious if you know would have broken the housing now.
Yeah. I mean, that's encouraged me now to try these sort of things because I've never tried it before. Yeah. And you made that look quite easy.
It was easy. That's why.
Remember to use a crapple as a heat source.
Yeah, a crapple worked quite well actually. Actually, my crapple station has worked very long as well, so I can't complain.
Very good. Well done, my friend.
Thanks a lot, Patrick. Appreciate it.
Thank you. Thank you. So, Detlef, do you want to play with some of your
your thingies?
We could.
And then we'll try some interesting soldering techniques.
Okay.
So, Detlef, over to you, my friend.
We were talking about last episode.
You're quite hidden behind the screen there.
Yeah, you are. Don't hide behind this.
I'll move it.
Can you lower it?
I can't.
Now we need to bring this down anyways. Yeah.
Oh, it's the microscope. It's not the screen. Okay, we have an extra screen over.
Yeah.
Right
look
here.
at this.
That's instead of the laptop.
Yeah.
Look at this. There's a new computer in the house.
So that was the problem.
Well, the computer is behind the monitor there, but
yeah, I thought it was the
screen. Can you see it? No, you can't.
No, you can turn it around.
Oh,
homemade.
Yeah.
There.
Can I zoom in? Where's my zoom? There's my zoom.
Yeah, there's a little mini form factor PC thing. and you see they call them Nook.
Nook. Yeah.
This is smaller than a Nook.
This is smaller than a Nook.
Yeah.
And what is it? 2 terabyte drive and 16 gig or something, and
so it's
enough of everything. Yeah.
A lot faster than the laptop.
The laptop was.
Well, it's faster than a laptop. I wouldn't say a lot of.
Compared to the laptop that was there, yes.
Yeah, that is true. Yeah, you got this right. Yeah.
A pregnant slug would be faster than that laptop.
Yeah, true. Yeah. I think still Ming won't be happy with that. But it's for free then.
Okay. Yeah. No more interruptions. Go for it.
Where was I? Last time when we were sitting around at the end of the episode, I think it was, I brought up some schematics where we were talking about replacements for 7805s.
Oh, yes.
09s, 12, 15s.
Yeah.
So we actually did that, and the order is somewhere on the way, I think, or something.
You're done.
Was that the one you sent to the bomb? No, it wasn't the bomb. No, this is one. Yeah, it's on its way with PCV.
Yeah. So we're working on this one. So this is going to be interesting because interesting chips there. But while we were on there, I had AliExpress open, and I thought, okay, let's get some of these little voltage modules here.
Yeah. Oh, there's
Oh,
a lot of them.
Let's do this just like that.
Okay, I have
oh, there's 3.
I have these ones at home. The small. This.
Just drop some voltage regulators on the table and
Yeah.
everybody's happy. So there's an interesting one in there. I want to show you this. This is something for your audio guys over there. Let me grab. This is the right one. This is the right one.
Okay.
You guys do the microscope. I do the clicking here.
I do the work here.
I'll sit back and relax.
Camera work.
Turn this 90 degrees. Thank you.
There we go.
So
And
of course
it's not as fat as you it shows. The aspect ratio is way off.
What the heck is going on now?
It's not working again.
Activate. Come on. We're still alive. We're still alive.
Yeah. Okay.
Is this something this thing you bumped into here?
No, it's this one.
No, this is still working.
Yeah, it's still working.
Yeah, this is on the other end. Oh crap! This is new.
Let me try just unplugging and
The
capture thing.
The capture thing. Yeah, try to unplug it. No. It's down there. The blue cable. The blue cable. The blue USB cable.
Oh, I see.
Yeah.
Unplug it, plug it back in.
New stuff always.
Okay, off, on.
All right. There was some.
Yeah,
This takes a second. Don't worry. Don't panic. Let's see if the second machine comes up now. Yeah, I got a picture.
Okay.
aspect ratios.
Aspect
Yeah, we need
ratio.
to sort this out next time.
The aspect ratio is still screwed. Yeah.
There's no settings. here.
F11.
Yeah, there's no settings.
As
so-
always. F11. Why doesn't anybody use F11 for browsers? This is full screen. This is every time full screen.
Yeah, I use F11 for browser.
So look at this. This is tiny. You saw the PCBs here lying around, and this is something. No, I stole it.
Yeah.
I just want to talk about this. Do we have something where I can point with?
Yeah. Tweezers.
Tweezers would be great.
Do we have
Do
some
we
tweezers?
have
No, but we have a comparison.
Ah, okay.
So that is a 7805.
So this is bigger. So this is bigger, but
It's
this
not
is not.
much, yeah, but it's not much bigger.
This is not the point.
This was
Get
still-
away with your 7805. Don't bring.
Don't contaminate your PCB.
Don't make the people
Confused.
don't confuse the people. Indeed.
Okay.
So what we got in here? So this is a voltage regulator thing. So you got a voltage in. No, I'm doing the thing here.
Here, that's better.
No, that is better. Yes, thank you. So there's a voltage in for.
It's off the-
No, it's completely gone.
Anybody think we're a bunch of amateurs?
Yeah, we are.
That's because we are.
I am. So you got an voltage in. This is where it says I. Then you got a ground. Then you got an out, like the 7805. You know.
Yep.
But if you look closer on here, there are two chips. There's one chip here. This is we know this one. AMS 1117 with a 5.0. This is a
5 volt.
linear 5-volt regulator.
Yeah.
Remember, linear. So every voltage is the voltage is too much. The excessive voltage is just turned into heat.
Yeah.
Yeah.
But over here, there's the second one. Look at this one. And the coil gives us away. This is a switching regulator. So what you got here, the incoming voltage goes to the switching regulator that produces something like, I'm guessing 7 volt or something. And this is fed into the linear regulator
Ah, so
over here.
it only drops 2 volts at 1 amp. That's 2 watts.
Indeed. So
Yeah.
A lot more efficient.
the efficiency is way higher than you do just using a linear one.
Oh, and no noise.
And
no noise.
Indeed,
Ah.
the noise. So our audio guys down here, tell me something. What would you think? What do you think about this, guys?
It's a smart way to do it.
We want 15 volt ones and negative ones.
You can do it. Just replace the AMS and then tune
The switch mode.
Yeah.
Yeah, because normally you'd have something like, say, 20 volts coming in, 15 out.
I'm not at the negative ones. If you want to buy this one, by the way, it has a little nameplate on the backside here.
DD38LOSA.
DD. Okay.
Yeah.
Sorry. DD38L. I don't know. I'm guessing LOSA. I'm guessing
Yeah.
here, from Electech Soup or something.
Text up, yeah.
Yeah, of course.
I like your name better.
Yeah, I know. another brand name here, yeah. So, audio guys. Give me
I
your
would buy
opinion.
this for video game consoles actually.
Well, you can have it. I got this because I was curious.
Yeah, I would use this on video game consoles that
Yeah,
need
I mean,
5 volts.
you have the efficiency.
Because you don't have any noise then.
Yeah, you effectively got the efficiency of a switching regulator to get the voltage close to what you want, and then the linear regulator, which is what you would normally use anyway. So
yeah, linear regulators. The only issue is normally the power supply, for example, for a video game is 9 to 12 volts.
yes,
And it's switched down to 5 with normal 7805, but that produces a lot of
4
heat.
or 5, 6 watts of heat.
Yeah, a lot of heat inside a contained box without a fan normally.
Yeah.
So this will help a lot because 2 watts is a lot less than 6 or 7.
Yeah.
So,
Well, I never got this right because I'm not an audio guy, but I always thought, well, switching regulators, they do their thing at around 500 kilohertz. 500 kilohertz, you know?
You can't hear
In
that.
audio, even a bat can't hear that.
No.
I know harmonics and all the crap.
yeah, exactly what I was going to say.
But the switching itself, it's so
The lower harmonics of the high frequency will actually be noticeable in the signals.
I think only an audio fool would notice.
Yeah,
Gordon, yes, these chips are in series. So the switching one, this is the little one, the tiny one over here.
Yeah, that thing.
This thing here, this is where the input voltage comes in. Then the chip itself drives us through the inductor with a little diode over here, and then it was passed over to the AMS 1117,
Yeah.
which is just something like a 7805 in a little,
Yeah.
a bit more modern in a different,
a little more efficient.
bit
That's
more, package,
So
That's nice.
And those caps are probably in series too. Yeah, of course. You do this when you say we need something like 50 microfarad, and you only have 22. So, and there's the question: what package can I get? And maybe it's cheaper to do 2 of them
Well,
before you get one of the big ones.
if
Yeah, true.
you're replacing like a 7/8 whatever with one of these, then the 7/8 whatever would then have capacitors on the output pin anyway to ground
True.
in the device you fit it into. I'd be very interested. I mean, obviously, it must be possible to make a negative version because a negative one has minus voltage coming in
And
anyway.
just a second, and Paul got the other point for putting multiple caps on there, because the capacitance gets, if you put them in parallel, the ESR actually drops, so you get faster reaction times out of this.
Correct.
Yeah.
Correct.
that's why you don't use massive caps normally.
Yeah. Or you use one big and a little small.
Yeah, exactly.
Yeah.
So,
But what we can do, and this is the thing while I'm normally buying these things. Let me get back.
can
on
we just,
camera.
before you move this off the screen, can I just ask something or what you think? So on this, you've got like obviously in, ground, out.
Yeah.
So if you had a negative one, would it be ground in, out? Because that's the normal pin out for 7/9.
I don't know.
You
One, two, or
you
seven,
should
I don't know. I haven't looked this up.
I don't think the negative ones exist. To
Really?
be honest.
Okay. 'Cause,
So,
Anthony, the max output is defined by once the coil, so the inductor. Without measuring this, I can't tell you that. And this is the biggest problem with these Chinese things. So maybe 1 amp is probably a good guess, but I would stay probably below 1 amp. And the little AMS 1117, there's a data sheet for that.
yeah, I think it's 2 amps max.
No, 800 mil, I think.
Oh,
yeah,
really?
something like that.
Yeah.
I have something similar, but it's a lot higher amperage, about 2 amps. But
Well, it's an AMS 1117. I have to look this up now, and I don't want to do this right now. 'cause
no, it's not.
I'm in the middle of telling people here. So, what I normally do, why do I buy these things? Because once they're practical, and this one was a really expensive one because this is not a standard one.
Yeah.
This is something €3.50. So
Yeah, that's expensive.
I normally don't buy them, and you normally get 5 of them for €1 or something.
Yeah.
So this would be my normal thing.
Yeah.
Don't go for high current applications, because high current, you can't use this with the cheaper ones.
No, you have to buy the really expensive ones.
Yeah. I buy these kind of things because we don't pay any VAT here. But at checkout, it tells me how much VAT I didn't pay.
Yeah.
So every time I'm a bit fed up, I just buy stuff and think, look,
I save money.
I save money. The taxman, well, I know it's not a savings, but like the taxman didn't get that money.
Yeah,
And
exactly.
it makes me feel good.
True. If you can stick it to the government, always do it.
So I buy stuff just to stick it to the government if I didn't want it.
Yeah. So why buying these things? For once, this is an approved design. So somebody built this, and they built this in the thousands. And so what you can do with this, you can take a peek how they do this and simply steal from the.
And make your own or incorporate it.
Yeah.
You know,
So
design
this is like 4 oh, so you just snap this off
yeah,
into individual ones?
these are 4 individual ones, yes. I have these ones. These are 500 milliamp maximum.
Yeah.
Yeah. It's still quite a lot for the size, obviously.
Oh yeah.
I wouldn't trust this. What did you say? How much?
500 milliamp.
500 mils. This is probably fine. Yeah.
And compare the size of that to the 7.8 whatever. Look,
Yeah. So,
it's about the size of the body.
but these doesn't get hot at all.
No,
Because
they
of
won't do.
switching. Yeah.
So that's why I use them. But I have noticed that some video game consoles introduce noise in the data signals and stuff with some of these. Not all of them, but some of them.
This is something different because video signals are way high frequency than
Yeah.
say audio or something.
Yeah, but that data signals are can be higher depending on the system and stuff. Not the systems I work with normally. What?
Yes, stress test them. Indeed, yes. This is what we're going to do when we get the
The-
ones we build.
Yeah.
Because
Comparison.
2 amps sounds good, but I want to be sure then. I want to see how hot this gets and what the little inductor on this one on these one does.
Yeah.
Yeah,
These
so-
are very interesting little devices.
Now, this is pretty much. Wait, I get you a picture here.
Yeah.
This is pretty much a thing that I designed here.
Yeah, it looks bog standard though.
Yeah.
Oh, nice. They are settable.
Or you buy them.
No, you buy them in a fixed voltage, but
You sure?
yeah.
There are
But
some.
you know what? We can look this up.
There are some of these.
There's a chip on there, right?
Yeah,
One.
there's-
What's the number on the chip?
1HVK.
Okay, 1HVK. Let me see if I can get a Google thing here going.
Yeah.
You could do this
Well,
on the machine over there.
While you're looking for the Google thing, I remember.
No,
that.
there should be something that you should do on camera.
Okay.
1HVK. Oh yeah.
What SMD code or something like that?
Yeah.
See, the internet works on this machine. No.
No. Wait. I think that was the one. HVK.
HVK 25V27 or 2.
Doesn't sound right.
Doesn't sound right now.
It doesn't sound right, does it?
It's not.
No.
Okay. Okay, give me a sec. 1 kilo ohm resistor. No.
Can you put chip marking behind the
SMD code. That'll do. Code. Try that.
HVK, HTK series. Are these the ones?
I don't think so.
Capacitor. No.
Nope.
Nope.
These are
Not.
capacitors.
These are capacitors.
I'm sure it was 1 HVK, the code lines.
Give me a sec. Get damn it. Sorry if you're looking.
They have the you have the browser in full screen. So
And
they see
what's the
browser.
marking? 1 HVY.
No, it's K. It's K.
You sure?
Yes.
Oh, it is 1 HVK, you're correct.
It's 1 HVK. So
SMD code, I don't know what that is.
regulator 1 HVK.
With a space.
Yeah. I thought I hit.
No.
Nope, nothing. So this is probably a regulator from China somewhere. So you
For
can't.
179 euros, it's not that.
No, definitely not.
No.
It's a switch mode power supply regulator. You found it on AliExpress, I'm guessing.
Could be. No, it isn't. No, it isn't. No. And I have no idea why now I'm running in. Sorry, I can't show you the screen. I could only do this with a video camera here because we don't have the screen.
Interestingly, I was going through some salvage components.
But before you tell the story about this, could you go through use a different one? We have enough of them. So try this one, for example.
That one.
This is a nice big one.
Whip. Yeah. Markings ground off.
Markings ground off. Damn it. Okay, got another one. You maybe want to switch the microscope on.
Yeah.
Oh yeah, right. Sorry. I see what I'm doing, but you don't. There we go. God damn it. There we go.
Yeah,
There.
thank you. So now we have a.
So this one is
Okay, let's see if I can see glare. Oh, there.
MP.
MP1584.
Yeah, this sounds way better. MP1584.
EN.
Go for it.
Oh yeah. MP1584.
84. EN.
Yeah.
You don't need.
Yes, we've got it. Data sheet.
DC to DC step
Perfect.
2 amps.
2 amp.
Well, I won't trust the inductor.
No, the inductor is quite small on this.
Yeah.
It's way smaller than the other ones. So
Okay.
it will probably run at
There's
2
a
amps.
Mauser. Use the Mauser link.
Oh, yeah,
up, but
sorry.
I know that.
Yeah, there we go.
And datasheet.
1.5.
datos.
3 amps. What?
See? Interesting chips, right?
Yeah.
Those are
Switching 3 amps.
3 amps is a lot
Yeah.
for that little chip.
Yeah, exit current 3 amps.
Yeah.
Spanish.
Scroll up a bit. Scroll up a bit. There's a datasheet.
Yeah.
Indeed.
Why is it in Spanish? God damn it.
It isn't in Spanish.
Ah, okay, there we go.
So, if you're at this point and you know what the chip is, you can check out the datasheet. And then you know, for example, we can put in the 4.5 to 28 volts.
Mm-hmm.
We know, wait, I put this out of our miseries here. Where are we? There.
ADSL applications and AM radio. ADSL. Okay, the chips are a bit old.
Switch it at 1.5.
Yeah, they're probably
megahertz.
not the newest one. But you get this here, and this is the
Yeah.
interesting part. You get a standard application, typical application. And there you can see how you would design your own thing around this. So, for example, we see L1 is 10 microhenry. So now the only thing you need to know is we need 10 microhenry and get a coil, get an inductor that can handle 3 amps for this.
So the output voltage is fixed on this?
No, it says scroll down to the thing. Can you zoom in a bit?
Sure.
Thank you very much, because there are people looking on their phones right now.
Yeah.
They're really desperate trying to see what we see. What you do here,
You change
you see the
capacitor
FB
resistor.
pin. Let me
Feedback.
share the mouse.
feedback.
Pin for that one.
This is a feedback. So you got normally this is comes from the output, and there's a voltage divider between 40.2 and 124k,
And this
and
sets
this
the output
sets
voltage.
the output voltage from this point here. So normally, when we scroll down, probably there's either way a scroll.
So the internal voltage ref must be about 1.2 then.
I don't care. I don't know, because the datasheet will tell me.
I'll just work from the ratio of the two to
Enable.
Yeah.
Start and shut down.
So this one is settable, pretty much.
Yeah, of course. They all
output voltage here.
No, there's my output voltage. You see?
R1 plus R2 divided by R2.
Yeah, so
Okay. Yes, exactly what Richard said.
Yeah,
Much.
1.2. Yeah.
yeah, and there's a demonstration with value of R1, blah 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 blah. A typical value for R2 would be 40.2k. This is what we saw in the data sheet. So then 0.8 is the reference voltage. So you get this.
Yeah, perfect.
Yeah.
Easy enough to understand.
Yeah.
I know some people dread data sheets.
Yeah, this is why I'm showing this, because I know some people are afraid of data sheets. You don't be. This is all in there. This is to help you develop your own stuff there.
The problem is the lingo and the jargon they use sometimes is really confusing, especially if you use micros. Have you seen the data sheet for the ESP32?
Of course I have.
It's freaking insane. I can program, and still some of the spots I have to read it 3 or 4 times to get how it works, especially the registers and stuff, special functions, because I want to do stuff faster than it does it in the IDE. For example, the sampling of the what's it called, the ADC. But if you want to do it faster, you have to do it in low level code.
Assembly language.
Richard could do a tutorial on how to read a data sheet.
That
Well,
would
that'd
be
be an interesting thing. I mean, how to go.
Psi voltage
agree.
Yeah.
propose this.
I think it's C voltage.
Okay, yeah.
C, Simon, yeah, C voltage. Sorry, mate. Yeah.
Psi voltage. Yeah, no, it works.
Okay. So, with all these voltage regulators, reminds me, I found something. So I was just going through a load of salvage components and kind of reorganising my collection. And I found something I've never seen before. And I didn't even know existed. And I want to see if you guys have ever seen one.
So you didn't know it existed, and you've been working for 50 years with this?
Yeah, no, I did not know this existed. So I'll show you what I found.
That's actually quite rare, I'm guessing.
Yeah, I didn't know it existed.
Huh.
Stick that under the microscope.
Yep, I will. Okay, so
Can you read it?
Yes, when you switch the PC over.
Yeah. Oh, so. Sorry, guys.
So, did you guys, anybody know that these existed?
7804s.
Yeah.
Whoa.
Oh,
It's a 7804.
I have never heard about it, at least.
No.
What? Where did you get this one from?
It looks some salvage stuff. I don't know what I salvaged it from, but was I a 7804? And I honestly did not know.
I have not seen that either. That's a new one for me.
That's a new one, yeah. You brought something that I never saw before, man.
Yeah, no. I may have the only one. A 7804.
Well, you know, if I would need something with around about 4 volts, I simply stick to a diode and into the
Is
thing,
that the Fairchild logo?
Could be.
Fairchild is now on semiconductor, I believe.
Yeah.
Look, there is. Guys, have you ever seen the 7804? Ever?
Never.
Look, yeah, never seen. No, I haven't. I mean, in 50
That's
years
a
of
very
doing this,
specific voltage.
I honestly didn't even. I had to look 3 times. I thought, no.
5, 3.3, 1.5 I've seen.
Really?
Yeah. I've seen a 7801, it's called, and it's a 1.5.
I've never seen but 7804.
But it's quite smaller than this.
I don't know if I'll ever use it, but it's a prized possession now.
Yeah, no.
I've actually got one.
A 4 is actually rarer than 1.5 because the 1.5 has a use. I wouldn't imagine
It must have a use.
But yeah, to be profitable to produce these, it has to have a main use somewhere. Probably a big order from a big company for some product. What did you rip it out from?
These days,
I don't know because I salvage a lot of stuff and then it all goes in the big tub.
Oh yeah.
And then every now and then I'll say, okay.
You do what I do. I have a big box and then I sort them out after a while.
Yeah. So this is what it is.
You do exactly what I do.
And it was in there. So I don't know what it came out of.
I wouldn't.
did you finish your bottle of your can of Coke?
I did finish my can of Coke because we need the can. Because today, Carlos.
Oh really?
Sorry, mate.
Yeah, okay, fine.
Carlos is going to do SMD desoldering with a Coca-Cola can.
What?
When you say it this way, it sounds weird.
Excuse me, what?
Okay, so
explain please, because I'm quite worried.
So one of the subscribers sent me a link to a video that was like almost unwatchable because it played this horrible music all the way through, and the guy never spoke. But what he does is he takes a Coca-Cola can and he cuts a small piece out,
a strip, okay,
a strip of it out, small enough so it will slide underneath SMD ICs and things like that.
Okay, that should work.
It's
thin enough.
Regulators here and to safety.
Yeah, because
once these guys start with this.
Okay, I see where this is going.
Yeah, so you cut the slither slides underneath the IC, whatever he wants to desolder. Yeah, like this. He slides it under, and then he hits at one side and he slides it sideways so it comes under the pins.
Yeah.
And because it's made from aluminium, the solder doesn't stick to it.
I know exactly where you're going with this. I've seen some similar things with. Could you?
Empties.
Yeah, somewhere.
And unfortunately, what we don't have is any kitchen roll this week. I forgot to bring it.
Yeah, that works. That's going to be thrown away anyway. That should be good enough, Rich.
If you dry it out with hot air, go on.
Yeah, no, I don't want the sugar sticking to the
So you want a bit of this.
Yeah. So just give me a second so I clean up the edges.
Yeah.
Because I just stabbed it and cut it out.
You did.
Anthony, this is exactly what we thought. When we saw this video, we were going for, why didn't we come up with this? Because this is so obvious once you saw it.
Yeah. He had like a rounded end on it rather than
Yeah.
like a sharp
No,
end.
don't worry.
And he made it bigger than that so he could hold it in. Yeah, you get in there.
Yeah.
Then he held it in.
Don't worry, I know what you're meaning.
Okay, so let's try it. It wasn't that long.
No, yeah, no, I just took a bit extra.
That we have a bit.
And then
I think you need to make it bigger, like a tear shape.
It was like a teardrop. Well, let's try it. Let's just try it.
Because you need something to hold this. This is way too small.
Let's have. No, that might be right.
And remember, you have heat transfer.
Remember, it needs to go underneath the ICs.
yep.
So it needs to go between the legs of the chip.
So it needs to be pointier.
Pointier, but not sharp point, but it needs to be narrower than that. Well, if you hold this against a chip under the microscope, you'll see what size we have.
Give me a sec.
Yeah, something like that. And now let's hold this under the microscope so we can see.
What I see, this one, I'm guessing. I'm not in camera. Oh, this motherboard is quite large. Okay, let's see, one of these.
Yeah, he was doing. I those you doing MOSFETs of. Yeah, these chip. No, not that one.
That
Oh.
He was using like on. I'm not sure it would go under there because it's.
No,
that's
that's
a bit
a big solid.
Yeah, but I guess like.
There we go. No, those are also.
And no, we don't have a deposit on these cans here in Grand Canaria. They're planning to do this in 27.
He was doing. You know the little transistors, the
For next year,
SOT23,
so-
Okay.
and the 8-pin chips.
There we go. This one's.
Yeah, yeah. So he's getting underneath these things.
Okay, so underneath these, let's see if I can. Okay, I'm out of shot. Sorry, guys.
Paul, exactly.
Yeah.
With a heat sink under the chip, you're screwed. You can't.
Yeah,
use
you
this.
can do this. Yeah.
I need to make a bit of space, or you need to use a different camera.
I'm just trying to see which one I can reach. Okay, there.
Yeah, there. So he heats up one side, the pins, with the soldering iron,
Yeah.
and when they melt, he slides that underneath the pins.
Okay, but why?
Try it on this. You see this little 8-pin IC near where you are?
This one.
Yeah, try it on that one.
Okay.
So you get under there. That's it. That's what he was doing.
Yeah. Okay, so it goes under.
Okay, so right. I'll just move this little power supply so you get it flat, or do you want to get the camera above? Do you want to do under the microscope?
That's fine. I can reach somewhat.
Right.
Let's get the IC in the shot.
You'll want some leaded solder.
Yeah.
I'll bring you the leaded solder.
You probably don't need.
You might not need them.
Go low end as far as possible, because I consider this a ghetto method, but I think from the look of it, it worked really well.
So it's just for taking off.
Well, things like
Does it switch
ICs and transistors.
No, it's not. There we go.
It does. It's 12 volts, so you don't have so much. You don't have
There won't plenty of
lots of heat in there.
Okay, so the idea is to slide it off with this, pretty much.
That slide under. So if like on an IC, let me find where's my finger on this. I'll find it.
Oh, it's way off. You're way out there. No, you're not going to fit that
Okay,
in
fine.
there. That I see.
Yeah,
Let's.
this will work.
Yeah, this IC.
Yeah.
So what he does is he gets a little thing,
Yeah.
slides it under the edge,
Yep.
then melts all the pins on one side,
And slides it underneath.
and
there.
slides it under the pins so it comes out sideways. If you see what I mean.
Yeah.
Your soldering iron's not powerful enough. He had quite a chunky tips. You need that soldering iron's nowhere near powerful enough.
Probably is the problem with the power bank. Wait, I can get you the.
I'm just
The
going
other
to
one-
I'm just going to speak to the church people and make sure they'll just keep the children quiet.
Yeah.
Twice this works better.
Yeah. Okay.
21. Okay.
Oh, yeah.
Yeah, you should have way more power now.
Okay, Richard will be back in a second.
Now he's screaming at the church outside.
At the children.
Yeah.
Like a proper old guy. I didn't say anything.
Don't tell him.
Not the man that one. Yeah. And
No, it's not going in.
Okay.
So if I put it on an angle like this, that should actually work.
yeah, you're not getting enough heat into even melt the
Yeah.
solder.
Yeah, and that's with 21 volts. Okay, so it's not going under the legs, but that could be the actual chip.
Do we need a bit more solder?
Add some solder first.
Yeah, I think so. Yeah.
I got under this one.
Yeah.
Do you want
I'm with you there.
Yeah. Okay, so if we put some fresh solder, this should work a lot better.
a little bit of flux?
I think the solder would work better in this
Yeah, I
case.
think the thermal transfer isn't.
Okay, bit of solder. Okay,
There.
Yeah.
This should work instantly.
we're off the screen a little bit. There.
Yeah, sorry guys. I'm trying to do this.
It's a
first.
difficult angle.
Yeah.
Yeah, that's it. There, Luke.
Yeah.
Then slide it out toward. That's it.
Yeah.
That way. Take your solder down the way. Give it a second or so,
Yep. There.
and then do the other side.
Yeah.
Yeah.
Dutch says it would have been off already with hot air.
Yeah.
But But Dutch, no, not everybody has a hot air gun.
Yeah. This is
So
like
this is very.
Oh, look at that.
quick and ghetto version,
This is very ghetto to get off a chip like that without a hot air gun.
but it actually works.
Let's try another one. Let's do a few more.
Let me
There's
just
some more.
check if there's no damage on the actual thing under the microscope, because I felt a crunch when I pulled it off.
No.
No, it seems fine. The crunch was from just the sliding of the aluminium on it. And the pads seem to be fine. Okay, that looks good.
So if you turn the board down,
I would want to actually try to take off
He was doing some quite big trips with this.
this.
Yes!
Wow. Okay.
You get my point, right? Because those crap.
Again?
Blood again.
Again?
Yeah.
Yeah.
Freshly cut aluminium is sharp.
Really?
Really?
Yes.
So you want?
Okay, you saw it live.
Do you want to
my
add a bit of
friends?
flux and solder on this to give
Just-
yourself a chance?
Just solder on the pins on the back.
Wrap copper wire around the chip. Heat
Yep.
up the copper wire and then chip.
Yeah, that's the method that I use
What?
normally.
I don't understand. Now you need to show this.
Okay, so you got some solder.
Yeah.
This feels like it would pop up anyway, so you just heat it long enough.
Yeah, but the problem is if you heat it long enough,
You melt all the
you
plastic.
melt the plastic.
Okay, so underneath.
Yeah, I'm going.
You want to go underneath the middle and slide
Yeah,
outwards.
sorry, I need an angle different to be able to slide.
Solder thick wire over the pins on both
Yeah.
sides and use a big solder tip
Yeah,
to heat it up. Same effect.
I know exactly what I mean. I have tried to do that a bunch of times and it works.
No, you need to get underneath.
Yeah, I know, and I'm melting the housing already.
Okay.
So this doesn't work for this because I can't get underneath. Okay.
UK Super Rascal, good evening, my friend. Carlos is still bleeding.
Yeah, I'm still waiting for it.
Where is it here? Right, you can get under there.
Yeah, but there is a pad right there.
Okay.
There's
yeah, no, this
a
is not
pad
working.
here. Yeah, no, it won't work.
Let's try if we turn the whole board around.
I know exactly what you mean with the thick copper wire. I'll demonstrate it in a few seconds.
You're clicking the mouse with the board, by the way.
I know.
Suddenly it's gone.
For some reason, we've got stuff on the base of the microscope making life very difficult for us.
Yeah. Which one did you want me to remove?
Those two. But
Those-
what I'm going
those
to
two
do is
should be
now,
doable.
I'm just going to move this power supply out of our way. So you can, because we're not using these. Right, now you've got a bit of space.
Oh,
Oh, space.
nice.
Yes, space.
Maybe I can actually do this without sticking myself.
Now you've got some space. It's underneath us at the moment, guys.
Okay,
Can
so
you fix that?
so
Dad?
let's.
Can you fix that so he's not underneath us? On the,
Yeah, if you move the camera to the right position, yeah, to the center of the screen, it will help. Indeed.
Okay.
Yeah, sorry guys. And
You can dremel off the tails of a bat, I see. Absolutely right. And by the way, you should do this. 'cause
Okay. This. Look at this. He's directly under it, and then slide outwards.
Yeah, I'm trying. There we
Look.
go. And that should be enough because thermal.
Yeah, and then go for the other side.
Yeah, I'm trying. It's hard because it's monocular.
Okay. Yeah.
Oh, this is a ground side, so this is more interesting.
Yeah.
Heat from underneath. Yeah, Craig, I know. But again, not everybody has a, what's this thing called?
Let me keep it still for you.
Yeah, this is bending. That's why
Okay.
I'm struggling to push
Yeah.
with enough force.
I mean, there's definitely other ways to do it. This is kind of like.
This is one of the janky ways. But it does work, as you can see.
This is very much the ghetto method.
And remember, there's a big heat plane there.
Yeah, no, this is a really chunky.
You need to get that last pin. You don't get that
all the
last
heat
bit
from
there.
the
There we go.
Ah.
boink.
It's off. So,
Well,
do
do
you
not-
have some thick wire? I want to show the other method he was talking about.
Yes, I can find some thick single core type wire.
Yeah. So,
Patrick Cohen, thanks for the trick. Thanks to you, I'm drinking a beer, so I'll have an empty can later. See ya! Beer tools! Paul, there's a trademark. Thank you.
Beer tools, yeah. Just some thick wire that would be.
Finding you some.
Yeah, perfect. I want to show it because I've seen it as well.
Has it got to be single core or multi-core?
Doesn't matter really. Just
Just
a bunch of copper, pretty much.
Earth wire from Twin and Earth I use.
Yeah.
So chop a piece off something like
Yeah,
that.
yeah, that works. That works fine. So rigid wire works better.
Let's get the camera on it.
Obviously.
So this piece of wire.
Okay, it's not copper, so it's a little harder with this. But,
Okay, well, okay.
but it should work.
Okay.
So the idea is you put this around the legs,
Uh-huh.
and then you just flood fill it with solder,
Yeah.
and it comes out with this.
Okay.
So let's see if this is enough, or if I have to strip some more. I have to strip some more.
Maybe if you stripped it before you cut it off.
Yeah. Okay. So, and to make the thermal transfer faster, you take the piece you want.
I might find some copper wire if you really
Yeah.
want copper.
I usually use cat wire for this. Cat
How about
series.
out of a
For cats.
Okay. How about? Oh, this is very thick, isn't it?
Yeah. So I use single core first.
Let me find you something. I might find something better for
Yeah,
you.
this won't work
Okay.
very well.
One moment.
It will if I twist it hard enough. Sorry guys, the prep wasn't
I
done.
have what
This
you
looks
need.
way more convoluted than
Yeah, no,
the
it's better for
can
very,
method.
very large
Here.
chips.
The beer tools.
Oh, there we go. That works.
Show the guys what we have.
We have some coaxial wire.
Strip it back first.
Yeah. No,
This is coax, satellite coax.
yeah.
Of course, you won't be able to watch any satellite TV. once
You don't have a wire stripper, do you?
Yeah, you got it in your hand. It's wire. No, a wire stripper. Yes.
I mean a real one.
Yes, I do have a real one. One moment.
The ones I use for telephone
Yeah,
cables
yeah,
and
yeah,
cat
yeah,
cables.
Yeah. I know what you're after. I'm just
Maybe I can manage without.
I like.
Sorry, John, we weren't prepared for this.
Oh, Jesus Christ. Okay.
Jesus said it doesn't have anything to do with it.
Yeah, no, it's his fault always.
Use a knife as well.
Not at all sacrilegious or something.
Well, it was my fault.
No, it's always Jesus' fault.
Oh yeah, of course. Of course.
I will get some flack for that, I'm pretty sure, but fine. Ah, there we go.
Okay, there's
Okay.
some solid wiring.
Very solid wire. Okay, so this is useful for multi-pin. This is actually not worth doing it on.
However,
But if you have a lot of pins on one side,
yeah.
this is really useful. Because
Okay.
you can get off the entire chip just heating the center of this.
Okay.
Just give me a sec.
Monetized. Demonetized, you mean?
Yeah, demonetized immediately. Sacrilegious content.
Yeah, but you can use the argument there that you're atheist.
Yeah, I am.
So that's
that should be fairly obvious for anyone that knows me.
yeah.
Alright, yeah, but this is only for the moment when you know that your chip is bad. Maybe you want to remove the chip.
And test it off
and test
circuit.
it, yeah.
What, cut all the legs off?
Yeah, so
Yeah, that
with the legs
works.
cut
It doesn't
off.
work very well with SMD ones. I've tried it. You usually pick the pads on the
Yeah.
PCB.
So this is for if you have a large chip. You do this. You put
Yeah.
a big U on it, and then you take.
Flux?
Can you get this in shot, please?
Sorry, I forgot the aspect ratio is not correct.
Yeah.
Right, I'll hold it still.
Yeah, thanks. And
Oh,
yeah, there was some glitch there. It wasn't me though.
of course not. You can't say it was an act of God.
No, he wasn't. Oh yeah, he was angry at me. After that comment. Okay, and then you have all the legs.
Yeah, I see that.
Legs flooded.
I see that.
So you heat up this, pretty much.
Okay. Really?
Yeah, and you get it off.
You want a pair of tweezers?
I use what the people doing this will have at hand.
So you heat the middle bit.
Ooh, this looks
This looks.
Yeah, you
not
should
healthy for the board.
What happens if you've got nearby SMD components?
Oh.
have. They all go loose as well.
This is horrible.
Yeah, it is horrible.
No, this is not a good.
Don't, no,
there
this,
we go.
don't. Where?
I don't like this.
I don't like this either.
No, and it's not getting hot enough either. So usually you use a very thick tip. I use the thickest one I have, and I put it like this, and just let the entire.
You can see the
metal.
I suggest, Carlos, you need some of those hot tweezers as
Yeah.
I've got.
Yeah, no, won't work.
That was a failure.
How do I increase the volt?
Good
the
question. Next
temperature?
question.
Temperature. Ooh, come on, go. How?
What, you gonna get it even hotter than that?
Yeah, 350.
Yeah, I think you're in the presets now. There's
Yeah, I don't know where I
probably
went.
hold on one of the buttons is doing the boost or something. No.
What?
Now you have to wait until the
There.
thing decides that you don't want to be in there anymore.
Yeah, okay.
I'm unlearning. Yes, yeah,
Yeah, no.
absolutely.
So this didn't work as well as they did on YouTube.
Does anything ever work as well as it looks like on YouTube?
Okay, try again. I rebooted the thing. I think you should have no power now.
Yeah.
Or you don't. Why not? Aha, I don't have to. I don't have enough hands.
Nothing works when you want it to.
Okay, try again.
So let's get this to 400 and something. Then.
There you go.
Okay.
So you have to hold it in to get boost.
All right.
380 is max. Okay. Let's torture the board a bit.
Okay, so change camera. That's it. We're on. I'm holding it still.
So this is copper, and it should transfer the heat quite well, but as you can see, it's not.
No.
No, not even close.
So the tin, the Coca-Cola can was a far better technique.
Yeah, it is, and I agree. I've only used this once for a very big chip.
Okay, so where's
with
your
very thick legs?
So where's your piece of Coca-Cola can? Let's do this one.
That's a good question.
That's a good question. Where did he put it?
Oh, it's down there. Okay.
Okay, let's try this.
Give me a sec.
Unremovable one.
How to remove all traces from a PCB? Yes, it feels like this.
Yep.
Yes.
Yeah.
I would agree with that sentiment. as well.
It's here somewhere. Have your piece of.
I found it. It's down there. It's in the can.
Okay.
But it's fine. I made a new one.
Okay.
A sharp one.
A sharp one, a
sharp
bit
one.
longer.
So I can burn.
Okay.
I can stab myself again.
Okay.
Okay, so
Microscope.
this is enough.
Yes, I
No,
know.
you need. Oh, sorry. You need to get it. Oh, that's it.
Yeah.
Under the chip.
And then one side first.
Sorry, Dad. Yes, that's it. Slide it outwards. Right, now wait a second. Right,
Yeah.
it's all solidified.
There we go.
Yeah.
Yeah, this is a lot better. I wouldn't have this.
Oh,
Oh,
then you
yeah.
can move it by itself because it's not.
Yeah, it's only on one
side.
And then clean up. Oh, look, the traces are fine.
Yeah.
This is something new for you, right?
Yeah, considering the electrics.
There's
Yeah.
a bit of flux. Give that another clean. It'll be good. Look at that.
Yeah, no, the Vectrix is a combination between drugs and being very impatient.
Okay, so guys,
Not getting abused. Yeah,
Yeah.
you know, when I think of these methods, I would choose the one that doesn't stress the board. So
much,
components more normally can be replaced, but the board. This is just you saw this before, this is just a old notebook thing. But remember, if you break the board here, if you rip pads off, man,
Yeah, it's
just
a lot
watch
of
Carlos
work.
videos.
Yeah,
yeah,
it's a lot of work to fix the board.
Yeah.
yeah,
Old boards like the Vectrix do have a tendency to rip pads without even putting heat in, because the technique they made, the PCBs with is a lot worse.
Yeah, I find those old PCBs, like the brownish coloured
Oh,
ones,
yeah.
which were made of like paper and resin.
Yeah.
And especially
Those are horrible.
And like the very old ones where they had hand-drawn tracks on.
Yeah.
You only have to show it a soldering iron and the tracks come off.
Yeah. I have had instances where the tracks were floating with the chip.
Yeah.
And they were not on the board anymore. The tracks were being held by the small, thin PCB traces.
Yeah.
But the actual pads were floating in there.
Yeah.
And that's without anyone touching them.
Okay, so the Coca-Cola can technique, what do you guys think? Have you seen that before? How would you rate it?
I haven't seen that particular one.
Craig says, what's the best way to fix pads? Don't rip them off.
Yeah.
That's the best way.
Sorry, mate.
But fixing them, I usually use wire, enamel wire. And if you have the pad kits from AliExpress.
Real life.
Yeah.
Can we show them? I get them on the screen.
Yeah. I bought 2 kits, and both were for very small components. Even if it showed a A4 page of the small pieces, the actual pad size was 0102 maybe.
Powerful iron. This was a TS. What's this thing? TS 101.
Yeah.
And we powered this by PD from 20 volts. So it's a standard tip here. This is not something special.
No. But mine at home, when it's running at max, it's actually more powerful than this.
Okay, real life pads.
But the tip matters as well.
Yeah, this is not an optimal.
No,
tip.
you need a wedge tip. Not a wedge tip, the other one.
Did I see this actually? Did you have those?
Yeah, I bought.
I have these.
I bought some similar to these.
I'll show you the ones I have. We can look at them now.
And they were the wrong size. They were so small. The card was this big, with 100 of them on it. So yeah, the pads are actually usable, but they are so small. Maybe a modern iPhone would use them or something. Nothing retro like mine. So, but if these are big enough, I will probably buy a set. Oh no, they're as big as the ones I have. Yep.
So
microscope, I think.
microscope, I think.
Yeah,
And then you have to switch over to the other camera.
Yeah, I'm on it.
I'll move this out of the way now.
So these are track repair kits or pad repair. There are square ones as well. Yeah, okay, you have some there.
Yeah, just open the plastic.
Press F11, please.
Oh yeah.
F11, okay.
Sorry.
So these are real life pads. You just saw they're about €3 for a whole pack of them.
So the problem for me is I do retro stuff. So these are too small.
Yeah, these are ideal for like things like HDMI connector pads and that sort of thing.
Yeah, iPhones and other.
Yeah, some big ones.
These are okay. These are fine to repair some stuff. I actually use the backing to cut out my own shapes.
Yeah. So if you can show the guys, if you go to this where you see it, if you lift this off and peel it back, you see it leaves the pads behind.
Ooh.
Yeah, so you can just pick them
so
up
then you
one
can
by
just
one.
pick them off one by one. Yeah, that's how it works.
Yeah. So I use the backing to make my own because I need bigger pads. But these are quite good because you can get them one by one.
Yeah.
Put them on, and they have some adhesive on the backside.
Yes, they have some of these.
To remind you guys, this is the actual size we just
Yeah,
saw.
it's quite small. Yeah. As you can see. Oh.
So the automatic.
Well, yeah, that's the little packet comes in. So
Yeah.
So this is this one.
And I bought one by mistake. That's the package is this big. Same brand, but it's a quarter of this size. And there was over 1,000 pads or something.
Orion says you can buy copper tape and cut your own traces.
Yeah,
of course.
Did you try this, Orion? And is the adhesive right for that?
Yeah.
Because I know that you can do this, of course.
Yes.
But
Okay.
the adhesive is.
I have some input
here,
on that. I have tried that before. You need to put solder mask underneath.
Solder mask under them, correct.
Yeah.
To stick them down with.
And then you use a UV to
harden the solder mask.
Simply don't rip the pads.
Yeah.
Yeah.
Didn't we get this tiny wire? You remember when we had one on the spool with all the colors and
yeah, I have that.
Do you know which one I mean?
I know exactly which one you mean.
I have
Carver, good evening, my friend.
I have a question for the audience later as well. I got a little crazy idea the other day with the laser, so I want to ask around before I do something dangerous. I'm going to do something
this
dangerous.
one. This one, yeah.
Yeah, I have
So-
3 or 4 rolls of those.
So this is wire wrapping wire.
Yeah.
It's very,
That's what I use to mod my consoles. So,
it's very thin.
This is the classic watch wire stuff.
yeah,
Yeah, and it's also
very easy to
single core. Let me.
and it's really easy to
Microscope.
de-sheath, let's say.
Yeah. Well, you sort of just did that with my fingers.
Yeah.
So this is very nice for like replacing like long tracks. Whereas those real life pads, are certainly for things like HDMI connectors and USB-C connectors, when you've ripped the pads on things like that,
You're screwed.
do we have the PCB weight ruler? We can just see if we can measure the wire gauge of this.
There we
I
go.
think it says this on the spool.
On the spool,
Okay, fine.
it's the AWG
Let's
size.
do it. So
A little bit underneath. On the there we go. But they haven't
okay,
marked which
so
one. Is
AWG.
30 or 28. They haven't marked which one. They usually put a dot on the one that
It's
is.
probably under this bit of tape here.
Yeah. I had 3 rolls of this stuff, and I use it for modding consoles.
Yeah, so this comes in very long,
Multiple colors.
multiple colours.
It's perfect for modifying consoles.
Yeah,
actually.
absolutely, yeah.
Because you need to keep all the signals separated and stuff, and you use different colors for different
Yeah,
wires.
yeah.
I usually use 2 of these twisted together
Okay,
for speaker cables and stuff.
not tried that.
For consoles.
Yeah, not for,
Okay.
not
Yeah,
for,
for a handheld consoles and
not,
stuff.
not proper speakers.
No. And those work quite well, even if they're not stranded.
Yeah. So I would suggest, guys, Jeff, you get some of this wire wrapping wire,
It's about €3 for this.
okay, and then the real life pads as well for the very fine work, like say connectors and stuff.
Yeah.
And you can probably repair most PCB.
Yeah, and considering you can use copper tape, like I said, the problem with copper tape is when you cut it, you have to have an extremely sharp X-Acto knife because you will bend and crinkle it, and then it's hard to get down. And I would put the copper tape on the pad where it is, a small piece, and then cut it out where it stands, pretty much on the PCB. But there's some issues with that as well. You will cut into the PCB, and so I would skip all that really if I could.
Yeah, the other stuff I can recommend for this sort of thing is this. I'll shake it up. So this is
paintable
yeah,
faces.
yeah. So this is silver paint.
Yeah.
Conducting silver.
Yes.
Lightsaber.
Not lightsaber.
It looks like lightsaber. Lightsaber. White silver. Yeah. Yeah. So this is literally conductive paint. So
It's liquid silver.
yeah, it gives it a good
With
shape
the binding.
to actually activate it, and then you either use a very fine paintbrush, or I find something like the end of a pair of like SMD tweezers, just dip them in. This is very good if you want to repair things like potentiometers, where you have the track,
Oh yeah.
and then at the end there's like a rivet which goes onto like the little metal thing, and often you'll find that where the track joins the metal leg, it loses the connection.
Yeah.
And you can paint this a little bit up the carbon track on the potentiometer.
A warning here. This is not as conductive as silver or copper. If you're going to run current through this, make sure the resistance is not too high.
Yeah.
Anne asks, does this work on rear car windows?
Huh?
Oh yeah,
What?
yes, for things like
Right.
yeah.
I don't understand the question.
He means for
the heater on
for
the
the
back
heater,
window.
the demister heater.
Yeah.
Yeah, but I believe
Yeah, it does.
I believe you can actually buy this stuff specifically for that job.
Yeah, it's the same thing, but it's less liquid.
Yeah.
Pretty much. It's more viscous, the one you use for the back
Yeah.
window.
So if you want to just see
It's conductive with silver paint.
that thing, look, it does say almost. Oh, it's light silver. It's not lightsaber.
Silver.
L100.
Silver is silver in German, right?
Yeah.
Silver.
Yeah, L100. Can we find this on AliExpress?
Probably silver
You've got
paint.
the thing computer over
Exactly, I have it right now. So I mean, we know.
Oh, I can distract them for a little while you search.
Okay, fine.
Okay, so I had an idea with my low power. Yeah, they get started already. I have a 10-watt laser I bought off Richard for a while ago.
Laser engraver.
Yeah, laser engraver, and it doesn't cut metals. It cuts 0.1 millimeter, 0.05 millimeter steel. It can't cut, but I want to cut something that's 2 millimeters thick and metal. So I was thinking around. Okay, 10 watts is not enough. It reflects too much. Copper sinks too much heat, and all around. So I was thinking of submerging the little piece of metal in acid with hydrogen peroxide, so I have an oxidizer inside, and heating up specific areas on the board to etch away, because hot acid is a lot stronger than cold acid. So cold acid that's 10 degrees hotter is twice as corrosive.
Yeah.
So if you go up, let's say 200 degrees, you can actually etch very specific patterns. And as well, you can also put solder mask on and etch off with the laser first the tracks you want to make and stuff. In this case, I want to make a small gear out of copper or some other metal that's hard, maybe steel or something.
Why don't you use the 3D thing they got on PCBWave?
Oh yeah, no.
And they can do copper. I'm pretty sure they can.
Yeah, I can get it made pretty easily, but I was thinking of making a project for a homemade extruder for my 3D printer, so I shared the project. Afterwards, I went away for people to get the gear, and not for, let's say, 20-25 euros each.
Okay. I have no idea what this
I have
stuff.
no idea.
So would you? Does someone know if that would work? If you maybe use solder mask to guard the corners and stuff, and just cut out the shape with a laser and some acid.
If you hear not loud fighting noises outside, it's not
Okay,
legit.
so the gas could, yeah, acid. It's not gas, so it's the acid boils off at 210 degrees or so. It's HCl plus hydrogen peroxide, 5%, just to have an oxidizer built, mixed in. So it's half the strength of nitric acid, pretty much. Yeah, noise pollution. It's horrible here. Yeah, I was advised to use a millimeter or two maximum of coverage of acid because of the diffraction. You will still get the same shape, but it will move to the sides. The diffraction of the actual laser light is not affected too much by transparent water. It's a blue laser.
No idea. I don't know anything about this.
Yeah, no, it's a bit of a weird one because I've looked around. I haven't seen any projects doing this. And it's,
maybe there's a reason for that.
Yeah.
Because
we have a lot of smart people in the chat. So.
That's true, but maybe they would say, go to PCBWave, let them manufacture the thing you need.
No, but I need something to iterate a lot of different ones fast. I'm talking about 10 or 20 a week, maybe. So
okay, yeah, this won't work. Yeah.
I've asked ChatGPT, of course. I've talked with it, and it gave me a rough calculation of the time for etching. So every millimeter of material in would take roughly 10 seconds if you use nitric acid. But nitric acid is too strong because it will melt everything around it. But the mix between muriatic acid and HCl, hydrogen chloride.
I don't even know what this is.
Yeah, and hydrogen peroxide is half the speed, so I can control it better, pretty much.
Okay, I think Richard.
I hear Joy make it stop. Yeah, believe me, the happy clappers are annoying.
Yeah, go to the Zumba class. Yeah, true.
So if anyone has any idea, maybe you can. Yeah, exactly. Nitric acid. I can use nitric acid I can make my own nitric acid. It's easy enough. You use a plasma arc and some air compressor and pump it through water, and you get nitric acid.
Sort of.
You have a black eye.
Yeah. No. No.
Yeah.
Sorry about it, guys. Let me quiet it down upstairs. So the church had started at 7, but they were being a little bit ambitious.
Yeah.
Okay, so we found some stuff. Silver paint, if you guys want to see.
Oh yeah. If you have any ideas, leave them in the comments, and I'll read them after.
Yeah. So silver paint, 99 cents, or you can buy a whole pack of them.
Syringes.
Yeah. Those real life pads were about €3.
That looks thicker. That looks like the one that you use for the cars, actually.
Yeah. DC conductor paint. Yeah. So there's different ones. So guys, it's very cheap. Buy some and give it a go. And then the last one was wire wrapping wire.
Yeah. Multicolor wrapping wire.
Well,
Edmund says,
Yeah,
buy
you-
a cheap CNC and mill the gear yourself.
Yeah. I am thinking of buying one. Or buying the laser of Richard, the big one. That can cut metal.
This is already sold, I think.
Yeah.
here we go. So
I thought that as well. But yeah, a CNC would be the best option. You're right about that.
this is the wire wrapping wire.
Yeah.
30 AWG 30. That's thinner than ours. It comes in different versions.
It was 28 or 30. It didn't say.
Yeah, 20. Okay,
So yeah, it's
so
about the same.
about €10 with the postage.
Really?
Yeah,
Oh, there's the multicolored one.
that's 200. The multicoloured one.
250 meters.
It's 250 meters. I mean, that's going to last you
Yeah.
forever.
I have 3 rolls and I haven't even run out of one.
Yeah.
yet, so.
Okay, so that final answers that one.
Okay, Craig says, can we talk about the 555 timer? It's so legendary, still learning about it and all these functions. Well, you know, this 40 years ago that they developed the thing, and they're still coming up with new applications for
Users,
this stuff.
yeah. There's
This
lot.
is a bit weird, yeah, but probably this is more on your end, Rich.
Yeah.
Well, actually, Detlef suggested to me, yeah.
Microcontroller.
Yeah. You don't need a 555 anymore. That's your answer, right?
That
Yeah.
would be my answer probably, yeah, because I don't need a cap. When it comes down to
It's a lot- it's a
component
lot
cost,
easier.
yeah, I'm cheaper with my micro.
Yeah. So,
Gay wire. Yeah. Thank you.
Gay wire, yeah.
Yeah.
Rainbow wire, yeah, true.
Rainbow
Yeah.
wire. Yeah. I agree.
so that suggested that maybe,
Wasn't me.
okay,
Sorry.
What-
Not on mute.
once a month, because we're doing the PCBWay videos as well anyway.
Oh, you got
Yeah, so what Detlef came up with an idea is we choose some device, maybe something unusual or something interesting, and we get some pre-assembled like reference boards or test boards, is that what you said? On PCBWay?
Yeah, the thing would be...
And we can play around with it, we can learn some different devices.
This doesn't fit to the 555 exactly, because...
It's not new or interesting.
Yeah, no.
Okay,
But
it
what
is-
I normally would do, I find a interesting chip, or
Yeah.
listen to you guys when you think, oh, this is an interesting chip. Get the data sheet. Of course we do. Get the reference application. So look how this works. Nothing complicated. I don't want to be with a microcontroller around this thing, but something where you can go for a little board, say 10 to 20 components on there, smack it together, get it over to PCBWay, then manufacture the thing. We play around with the thing, and we all learn something on the way.
If it's good enough, we put it out so people can download it and buy it from PCBWay pretty much.
Yeah, so what do you guys think of that idea? Unusual devices or
Or
just
chips.
interesting devices?
There are really funny micros and stuff from China that don't exist here. But the problem is usually the programmers for those things.
This is probably a bit more in line with what EveBlog is doing. Whether that fits on my channel, I don't know.
It does, but those are too complicated to do a small project on, pretty much. But there are similar things.
You know, there's a time limit I want to put in there. So I
agree.
don't want to spend 2 weeks of developing something to test the chip.
We were thinking more things like you can get like chips that are a potentiometer that you control, like a digital potentiometer.
The voltage regulators.
And the voltage regulators, you're looking at now.
This would be the first thing, because this is a really interesting thing that pushes 2 amps and a little SO2 23, and something like that. Yeah. Fake transistor tester, yeah, I think this we were talking about this morning.
We're talking about this morning. So the fake MOSFET tester, I've sent the PCBs, they should be here soon. We have a video I'm doing this week, which is the fake transistor tester. So this will test transistors. I'm going via the technique that fake ones won't pass as much current as they should do.
Gordon, a logic tester. Do you mean a little logic analyzer, right? Look on my old YouTube channel. On the English one, there's one. Without a microcontroller.
Yeah, super easy build. Super easy build, really useful.
Craig, weather stations. You can do weather stations all day. So sorry if I'm not jumping right now on weather stations, but then you need some infrastructure for that. So
you need weather.
And
we don't have anything else than sun.
Yeah. Ideal diode. Yeah, Paul, you said it before. Yeah, I got the idea. Ideal diode and ideal bridge rectifiers. Yeah.
Yeah.
It could be for example, this could be an interesting thing, but we need a controller chip with that.
Okay, so the fake transistor tester video should be on Tuesday or Wednesday this week. That's like next on my to-do list, pretty much. And we're having a Call of Duty video this week, guys. I haven't done one for a few weeks. I've been a bit busy, but I have been buying some stuff.
Yeah, I haven't been there at all.
Oh, shall I show you guys what we bought last week for €10?
What was that?
Yeah, this is
ZN414, Mike. It looks like a transistor was a full AM radio.
Oh,
damn! We don't have any AM stations here left, I think. But I need.
Nylon doesn't have that.
I'll do a screenshot now because I can't remember these things for the life of me. I'll look this up, man. Thanks. Anne says the rest of expensive, really thin alias all the way. Okay, yeah. Hi guys, first post. Hey, Ade Field. How do you say this still German, English? First post, but thanks for the channel, great work. I have the CNG224 from the
4-bit computer. Wow, Gordon.
I don't even know what this is, mate.
A 4-bit computer, Gordon. Do you really think that highly of us?
See, remember me saying about I have a time frame for that?
That's a year-long project, pretty much.
Oh, this thing.
Yeah, when I worked at ICL, my first repair jobs there were 6-bit computers that used bit plane.
Oh, Jesus Christ.
It's like you had to learn knitting to fix them bit.
I remember the knitted memory.
The knitted memory, yeah. So, guys, not this Sunday, but the Sunday before. Death myself were wandering around and I found this, or I said to Death, what is that?
A digital reverberator. It's not a sex toy.
No, so I asked the guy how much, and I think he said 15, and I said how about 10 DS. He said see, so he sold it me for €10.
So this machine has been replaced by one plug-in in Cubase.
We haven't tried it.
We haven't tried it, but I thought, as a side to the Call of Duty as well as the old computers, any of you guys interested in this sort of old hardware? I'm not sure what state this is in.
It's cool. Give it that, and it's a good brand, so it's Yamaha.
I had a look on eBay. It seemed to suggest that these are selling for 200 or 300.
Yeah, that doesn't surprise me.
This one,
yeah.
Somebody's cut the mains lead off it.
Then it has a short, not mostly.
No. Imagine this in a studio environment, and they need to strip down all the things, and the power cord is probably somewhere in the back and unreachable, so you could simply snap it.
The other option is it came from an auction, and legally, unless you've been pack tested in the EU, they can't sell them, so they cut the wire off.
Yeah.
Oh,
that's another one.
But that's certainly in the UK. But here, I think a pat test here is, are you Irish?
It has MIDI. It has MIDI. Yay.
Yes, it has MIDI, and it has a remote control port as
Well,
well.
we don't have
the MIDI. You can hook in practically any computer, any phone, I guess.
Yeah. Anyway, so I found this, and there was some similar equipment down there actually. But one had some broken buttons on. But
this is studio equipment.
Studio equipment. So anyway, guys, we'll have a look at that. Car booty style. We'll connect it up, see if it works.
Do we run Q&A?
Yes, we can do. I'm still trying to catch up.
Yeah, you know it's hard.
Yeah. Audio stuff like this. Yeah. this is not my forte. So if you high voltage, if you have something where you say, oh, this chip is nice for audio stuff, you're probably talking about the Yamaha, right? Sorry, mate, didn't get you there. Okay, well, this is the video. Give me the audio hookups.
Yeah, I didn't have any RCAs, no. Detlef knows a bit about music, so and studio stuff.
No.
Yeah.
Give me a guitar and I'm happy.
Yeah, exactly. But you know what hookups go to the guitar and stuff. Not like me. I'm completely tone deaf and I don't care about music at all. Because if
we're doing on the 21st. We're doing a little concert over there.
Oh, okay.
Ken's planning on doing what's it called after work. So we'll hang out in the coffee and do a rehearsal as we usually do.
Oh, okay.
Yeah.
Maybe.
Yeah, figure out.
That Yamaha Rev 7.
Yeah, there it is.
Oh, you can buy them for about €100 apparently. I don't know if mine's even working.
And working.
But does anybody actually sell them? This is the question.
Yeah.
Oh, custom OLED LED. This doesn't sound nice.
No.
So probably the LEDs start dying in there.
Yeah, so that's probably a custom or a common failure point on those. There it is.
Well, there you go. Somebody sold one
270.
for $270 on the 5th of March from Romania. So that was recently sold at $270, and that's sold.
37 delivered. That's cheap.
It does say best offer, but normally if a best offer was made, he puts a line.
No, it shows the best offer.
Oh yeah, I've never noticed how he puts a line through. But yeah, somewhere in that region. So for €10, it's got to be worth buying. It's a kind of reverb synthesizer, it says.
That's a kind of man.
Yeah. I would have guessed that with the name, actually.
Yeah. So yeah, that's it.
Old audio equipment will always sell because it has a specific sound. It sounds different than a plugin or a program that does the same for a lot less. Okay.
Edmund says, from Austria, by the way, I read this. You guys are really great, by the way. Greetings from Austria.
You are not wrong,
Cheers.
Paul.
Thank you, mate.
I love 8-bit music. I have a few tracks that I listen to, and AI is making it really easy to make my own.
But is it yours or is it the AI's?
No, it's mine because I pay the monthly fee, so I actually have a full copyright.
You know the saying, 2023 was the last year where you could really be sure that the music you're hearing wasn't made by AI.
Yeah, and it's true.
I know all the crappy reggaeton that's playing around these islands.
Yeah.
Oh, reggaeton.
This can be done with any stupid AI.
Yeah, with the bad ones even.
Yeah, with the bad ones, yes. Well, if you call in reggaeton music, this is an insult to music.
Yeah, it's not music.
No, it's not music. No,
it's like
this is not music.
Saying hard metal is music.
Exactly.
I'm going to piss off someone.
Yeah.
Don't go there.
I mean the not lordy or even worse. I mean the ones that scream at the microphone and don't do anything else. Yeah. You know exactly.
I know exactly.
Even with these good songs, yeah. Well,
it sounds like he's drowning or dying or something.
Okay, guys, we have a bit more than 10 minutes. Ask us anything.
Yeah.
Well.
Yeah. Go for it.
Go for it.
I'll see if I can answer anyway, even if it is out of TOS.
Yeah. Craig says I have a friend that has a Ferguson 6349. The picture keeps rolling around. Or any ideas?
Is that a TV?
I don't have an idea what a Ferguson 6449 is.
Is this a?
If it is
it CRT television?
If it is, it's probably a timing issue.
Okay, if the picture's rolling around vertically, then it's lost the vertical sync.
No.
Well, you know...
are we talking CRT television?
2025? Does really anybody use something with a cathode tube?
I want one because that's the only thing light cans work on. So yeah, must be a TV. Yeah, it's a TV.
I use my oscilloscope with a cathode ray tube.
Yeah, those work fine.
It works excellent.
Yeah.
Okay. So if it's rolling vertically, you should be able to find schematics for this. And there's the oscillator for the vertical scan, which is 50 hertz. If it's a
okay, so it can roll.
So it has a sync pulse.
Is it vertical or horizontal? The rolling, because that depends on a horizontal or vertical sync.
Yeah.
Which one is off whack? And usually it is either a small variable capacitor you can
A
adjust.
variable resistor, actually, a trimmer.
Oh yeah, the trim part. Sorry, or it has
Something wrong with them.
in the software you can.
No, there's no software. These things are analog.
No, but there are TVs that have a special menu that you can set up.
Not on these CRT TVs, you don't.
Yeah, no. I had one with the
Okay, what's it
manual
say?
adjustments.
Size something for Carlos.
C voltage. Go with the one Richard has.
Well,
The soldering pump.
You need to read the question so that people can read this.
So
I desoldered a lot of components. What desolder vacuum sucker would you recommend? Not the one you're using in the video.
Okay.
no.
Can I just ask, side voltage, are you desoldering these for salvage or as part of repair work?
If it is for salvage,
Well,
that you can just use an oven, pretty much.
And Gordon, I'm so happy that you're saying this. Bin it and buy a decent LED monitor, because 2025 there's no reason to having a TV, an old TV.
A
like
CRT. Okay,
Yeah.
so it depends on the use case. Like I said, light guns only work on old TVs because of the scanning.
yeah.
You know the guns.
the
I know, but what would you use this for?
Playing old games of live ones.
That's pretty
Retro.
much it. Yeah, that's pretty much the only use case in my mind. And I'm guessing
Side voltage, both really, okay.
I can answer that, Craig. You clip alligator clip with a long wire and a screwdriver to the chassis where the ground is, and then you prod the screwdriver underneath the little cap for the CRT, and you hear a pop, and then it's discharged. Keep the TV unplugged when you do this, and you should be fine. But have a screwdriver with a big chunky plastic handle, no metallic ones.
And then you clip an earth lead to the
You
screwdriver.
know that there's a tool
Yeah.
for this, right?
Oh
not,
yeah,
not,
yeah.
not screwdrivers.
It works with a screwdriver.
Craig, please don't kill yourself.
Can I add,
Please.
when I did my City and Guilds in the 1980s, which
Oh,
was
yeah.
in the UK, which is a professional qualification, they actually taught us to discharge CRTs with a screwdriver.
Yeah.
And we clipped a
It's
crocodile
the same
clip lead to the metal pot, the screwdriver, clipped it to the chassis of the TV, grabbed hold of the plastic handle and stuck it under the car.
If you want to see an example of that, Craig, just go to my last video for the Vectrex. I do that there because I need to discharge it too when I work on it. Because it hurts a lot to get a zap from that thing. And
You
TVs
did put a ground lead onto the soldering the screwdriver.
I did.
You were relatively safe if you do it that way.
Yeah.
Side voltage. Can we just show them a picture of the screen we have? So I have coming to review from AliExpress one of these. So they're a pot which is filled with solder. So I bought some solder bars, which is like 500 grams. You fill this pot in, you switch it on, and then after some little bit of time, you have like a pot full of molten solder right to the lid, or rather the edge. And you take your PCB you want to desolder stuff on, you rest it on top of the pot, and they just pick all the bits off it.
Yeah,
But
SMD. Isn't this for retinning your tips?
You can use them for tinning wire, but they're also, I believe, very good for salvaging components from single-sided PCBs.
Seen anyone do that.
Well, I'm going to be making a video as soon as it arrives. It's on the island somewhere now. So when it's
I
here,
used something similar
This is normal here.
to retin my soldering tips before they were disposable. It was a long time ago.
yeah. So I'm going to use one of these.
Jonathan says, nice leaded fumes.
Oh, can I just add? Okay, so the solder that you fill these pots with
It's unleaded.
is no flux in it. It doesn't.
But
There's no such thing as leaded fumes. Lead is a metal; it doesn't give off fumes. It's only the flux that gives off fumes.
True. Okay. Fine.
So, however, I have they're here actually.
But still, that amount of lead liquid.
Yeah, Paul, exactly. Solder pots are for dipping wires and put in production.
Yeah.
So if you're soldering a lot of wires in making a TV, so for example, that we had before, then you normally have some flux somewhere, you smack it in there, then you hold it in the pot, and then you have this
Tin wire.
thin wire.
So
Holy shit.
as is typical, the consumables arrived before the actual solder pot.
Yeah.
So I have the this is what you stick in.
It looks like a battery.
It says on it, it says tin 63. This is probably leaded. You can get them unleaded as well. So,
Yeah.
so these are big metal bars.
Yeah.
And I have 2 of these. So they cost me about €6 or something.
I'm very strong. I say very soft metal.
This probably can handle a lot of current.
Yeah, it can.
Yeah. So you melt these, but these don't have any flux in them. So you melt them into well, you cut them up with a big snips or something. You melt them into that pot.
You can just stand them up on one end and they will melt it.
Whichever. Then when it's all molten, you fill it to the very top, and then you just rest your PCB on the top of all the molten solder. This big pool of molten solder.
I've seen
just
that,
bits off.
but in an Indian, in an Indian video.
Yeah, so I'm going to do it in English.
But
video.
they used a big crucible instead.
Yeah, this is like the crucible, but it's electric. But what I suggest you do is you stand the crucible inside something like a baking tray. So if it falls over, all this liquid solder is not going to run onto your legs or something, yeah?
Yeah, so you don't kill yourself.
Fishing weights. That's an
Fishing weights would probably do it.
Or you use them on New Year's Eve for doing the little thing.
Aren't fishing weights made of bismuth nowadays?
I don't know. So
because of the toxicity of it.
Probably. So when that arrives, hopefully next week or so, we have a video. Let's go try. I'm going to try and salvage bits using that, and then we'll see. And they're cheap. What, about €12 to buy one of the machines, and about another 10 for the consumables. Okay.
Yeah, CRT capacitors are extremely dangerous, but if you discharge the flyback, you discharge the capacitors that are connected to it, so it's fine. But be careful, capacitors always.
Can I just mention that there's usually no capacitors on the HT on the CRT because the tube itself is a capacitor, like a Leyden jar. It's glass with an aquadag coating on the inside.
I think somebody said this in years.
Yeah, aquadag.
But there are some capacitors sometimes behind the flyback that charge up to a couple of thousand volts just to keep it stable. Depends on the size of the flyback and stuff, but yeah, normally there are no caps, so you should be fine.
Patrick says lead does indeed evaporate when it's liquid. I'm not a chemist here, so
he probably is right, because everything evaporates
and the other
when it's liquid.
The other thing is your body could not actually absorb metallic lead. It can only absorb organic lead compounds.
Yeah, like lead oxide. But lead oxide is created in the air because of the oxygen.
Yeah. But anyway.
Yeah, no, just be careful.
just be careful, guys.
We haven't died yet of lead poisoning, and we do soldering every day.
Yeah.
And you have done it for 60 years? No,
50.
50. So it's not that.
Yeah, more than 50. more than 50 years.
And simply don't lick the boards.
Yeah. Fume extractor, no. Mouth protection, no.
No, not even wearing a mask.
When we lived, I see I have like 100 engineers in one like big building, and there wasn't any filtration. No. The only air filtration is if you work like on the magnetic drums, and that way it was like the dust-free thing. Like
yeah.
No,
exactly. It depends if you have a pre-exposed condition like me. I'm asthmatic, so I have to be careful. But even I don't suffer from anything really. Yeah.
Okay.
And my asthma comes from birth, so it's not from the from the fumes.
Maybe time for one more question.
Yeah, a fume hood would be awesome, Paul. I would love one, but have you seen the price on those things?
Yeah.
I can't afford that.
Jonathan says it's right. The lead ends up in the bloodstem and stays there for life. And University of the US did a long-term study.
So you guys get heavier.
But
Yeah, true. I know lead poisoning is a thing. It usually is more of a thing if there are compounds of lead or
yes.
Soren on YouTube puts this in his mouth. Really?
Yeah.
I mean, there's no really need for this. So,
he was just demonstrating probably that it's not toxic.
When we were in chemistry lessons at school,
so YouTube sometimes is stupid.
Yes.
I think it's
don't do this.
Don't tempt fate. Pretty much.
I think this is a modern protectionism thing, because when we were kids at school, so 13, 14, 15 years old, in chemistry, they get like a tray, they pour liquid mercury in and put it on the jet, we'd all poke at it with the fingers and push the blobs around, and we all survived.
Yeah.
And nobody seemed to think it was a problem because metallic mercury, you can't assimilate it, so to speak.
Yeah, exactly.
Maybe the Borg can,
64. I agree. I also use the stuff that doesn't bother me much, but
Okay, and Roland says again, okay, this is all the chemicals he's getting in here. A quick Google points out that lead doesn't evaporate at normal soldering temperatures, so we're probably are pretty safe there.
Exactly.
Yeah.
And Rich is right. The smoke you're seeing coming out if you solder, when you're soldering something, it's a flux.
Yeah, it's that what burns
And there's
off.
no lead in it, it's flux.
Yeah, it's not good for you either, but let's
Lick
be
the boards.
honest.
Don't lick the boards.
Yeah.
Don't eat your rest solder. Yeah, and this is a nice thing to
And
finish the
and
thing.
do it.
Okay, yeah. So
everybody, have a good night. See you in 2 weeks.
2 weeks, yeah.
2
Yeah.
weeks, like always.
Yep.
And yes, we do St. Patrick's Day. Whoever asked us.
Yes, we're doing St. Patrick's Day video, definitely.
Oh, okay. I didn't know that, but sure.
All right, you guys. Have a good one.
See ya.
Bye.
See you around.